Hello everyone, welcome to my channel. This is Karuna, teaching the course Microprocessors and Microcontrollers. In this video, we are concentrating on addressing modes of 8086 microprocessor. Introduction. Each instruction performs an operation on the specified data. Hence, an operand must be specified for an instruction to be executed. In last videos we have discussed about the processor. Before going to perform any operation, processor needs to fetch the instruction from program memory and processor needs to fetch the data from the data memory. Before going to design any instruction, you should have the basic knowledge on addressing mode. To perform any operation on the data, processor needs to fetch that data. Data may be available in the accumulator, general purpose register, memory location. Coming to addressing mode. The definition of addressing mode is the way by which an operand is specified for an instruction is called addressing mode. Basically, instructions are categorized into sequential control flow instructions, control transfer instructions. So in sequential control flow instructions, control will transfer to the next instruction in the program after execution of the current instruction. In second case, control will be transferred to some predefined or specified address in the instruction after execution of the current instruction. So based on this concept, the addressing modes are available. Let us see. Addressing modes for sequential control flow instructions. Immediate addressing mode, direct addressing mode, register addressing mode, register indirect addressing mode, based indexed addressing mode, register relative addressing mode, relative based indexed addressing mode. Let us discuss one by one. Immediate addressing mode. In this addressing mode, data is available in the instruction immediately. Okay, for example, that data may be 8-bit data or 16-bit data. We can use in the instruction. For example, move AX, 0005H. Data must be in hexa only. That's what here we are using H. Move AL, 05. This is 8-bit data. This is 16-bit data. You can use any instruction. Okay. So this kind of example comes under immediate addressing mode. Next, direct addressing mode. The 16-bit memory address of the data is directly specified in the instruction, that is 5000H. This is the address of the data. Here in this example, I am taking move instruction. Okay, so transfer the data available at this address to the AX. Generally, data is available in the data segment. That's what here data segment is used. Assume data segment address is 1000 and here we can say 5000 is the offset address. Okay, 16-bit offset address. These are the registers available in the processor and this is memory. Okay, so DS having the starting address or base address of that data segment. So DS contains upper 16 bits. That means that address mentioned in terms of hexa, 4 digits. Okay, but actual address bits are 20 bits. So we have to convert this 4 bits into 20-bit address by multiplying 10 to the base address. Because base address must contains last digit should be 0. Okay, so this base address will be added to the offset address, whatever the mentioned address in the instruction directly. Okay, then generate the physical address of the data 15000. Okay, add 10000 to offset address 5000 that is mentioned in the instruction. Then generate physical address 15000. At that address, whatever the data is present in the memory, that will be transferred to AX. ఎందుకంటే ఇక్కడ మూవ్ ఇన్స్ట్రక్షన్ వాడాను కాబట్టి ట్రాన్స్ఫర్ అవుతుంది. సపోజ్ యాడ్ వాడామనుకోండి, యూ కెన్ యూజ్ యాడ్, సబ్, వాట్ ఎవర్ ఇట్ మే బి ద ఇన్స్ట్రక్షన్. Okay, that perform add operation between the content of memory and the previous content available in the AX register. Okay, then if you use add instruction, add operation will be performed and output will be stored in AX register. Address of the data is directly mentioned in the instruction, comes under direct addressing mode. Okay, next coming to the register addressing mode. The operand is available in the register specified by the instruction. Move AX comma BX. Here I am using transfer instruction for the sake of understanding. This is destination and this is source. Destination and this one is source. Okay, source operand is 1, 2, 3, 4 will be transferred to the destination register AX 1, 2, 3, 4. Okay, here operand is available in the BX register. Okay, next coming to the fourth addressing mode, register indirect addressing mode. Register indirect addressing mode. The address of the operand is specified in an indirect way. The effective address of the operand is available in either BX register, SI register, DI register specified by the instruction. See, effective address can be mentioned in either of these registers, BX, SI, DI. For example, I am taking here BX. You can take SI, DI also. Okay, so move AX comma bracket of BX. Here we are talking about the data. That's what I am taking here, DS. Okay, content DS 1000 and BX is having 5000. Okay, so how physical address of the data generated, DS content is multiplied with the 10, then it will be added to content of BX. Okay, then 15000 physical address of the data is generated. Let us see diagrammatically. Here these are the registers, all are 16-bit registers. That's what 4 digits, nothing but 16 bits. Okay, 16 bits can be represented in terms of 4 digits in hexa form. Okay, so DS 1000 to generate physical address, 10 will be multiplied to the content of DS, that means base address. Okay, starting address of the data segment. Okay, this is memory, this is the processor registers. Okay, then this DS content multiplied by 10 to generate 5-digit address. That address will be added to the content of BX. Okay, then physical address is generated 15000. At that physical address, whatever the data, here I am using 3412 data, 16-bit data, because I am using AX. Here you can use AL also, 8-bit also, but here I am using 16-bit register. Okay, that data is transferred to AX register. At that physical address, whatever the data is present, that will be transferred to AX register according to the instruction. Now coming to the based indexed addressing mode, means offset address is present in base register as well as index register. For base register, you can use BX, BP. Index register, you can use SI, DI. The effective address of the operand is the sum of base register content and an index register content, both of which are specified by the instruction. Instructions లో ఈ రెండు రిజిస్టర్స్ కూడా మెన్షన్ చేయాలి ఈ అడ్రసింగ్ మోడ్లో, బేస్ రిజిస్టర్ అండ్ ఇండెక్స్ రిజిస్టర్. I told you AX, BX, CX, DX. Special function of BX is used to store the offset address. That's what here I am using BX register to store the offset address. The effective address of the data is the sum of base register and index register. Here data is available in the data segment. That's what I am using, data segment multiplied by 10 to generate 5-digit address. That will be added to the index address, content of index register, source index register, and then that resultant will be added to the content of bx, then generate the physical address of the data. Let us assume this is the data segment. Okay, at that physical address, whatever the data is available, that will be transferred to the AX register according to this instruction. This we can call it as a effective address, summation of two offset addresses available in SI and BX register. Then if you add effective address of the data to the base address of the segment, then physical address of the data is generated. So physical address of the data can be generated by adding the offset addresses available in SI and BX registers and content of DS. Next, coming to the register relative addressing mode. Relative means 8-bit displacement or 16-bit displacement. Relative. Register, we can use either base register or index registers. Okay, anyway, effective address is the summation of 8-bit or 16-bit displacement and the contents of either base register or index registers. Okay, so I am using here example move AX comma 1050 BX bracket of BX. 1050 is the relative address, or we can say relative displacement, or we can say relative address. Okay, so this may be 8-bit or 16-bit. ఇక్కడ నేను 16-bit తీసుకున్నాను. 4 digits ఉన్నాయంటే 16-bit అని అర్థం. Okay, so 4 digits, 4 4s are 16 bits. This is mentioned in hexa only. Okay, so data, because of data I am using data segment. Assume data segment base address is 1000 and BX content is 2000. Then relative address 16-bit relative address is 1050. We can call it as a offset address also. Okay, so here 5-digit address is generated by multiplying 10 to the data segment register content, base address of the data segment register content. Then that will be added to the content of BX register, that is the offset address stored in BX register. Then 12000 is generated. Then offset address 16-bit displacement 1050 relative address is added to the this resultant address. Then generate physical address of the data 13050. Here see, this is the base address, this is the offset address available in BX, this is 16-bit displacement. So this is known as effective address. The physical address is 13050, physical address of an operand. Okay, at that physical address, whatever the operand or data available, that will be transferred to AX register according to the given instruction. Relative based index addressing mode. Relative means either 8-bit or 16-bit displacement. Based means you can use BX or BP. Index means SI or DI. You can use these three offset addresses to store the data. Okay, for specifying the data you can use in this way also. The effective address of the operand is the sum of 8-bit or 16-bit displacement and a based indexed address. For example, move AX comma relative address 1050 16-bit address taken BX SI. Assume DS is 1000, BX is 2000. We should not say 2000, 1000, 5000 because it is mentioned in hexa only. Okay, that's what we have to use. We have to mention 5000. These are the registers available in the processor and this is memory. Okay, so the data resides in memory. Okay. At which address? So that we have to calculate. So that is DS. To generate 5-digit address, we have to multiply 10 to the content of DS register, that is the base address of the data segment, and that will be added to the SI and BX. Here SI and BX. Okay, then generates the physical address. Here relative address is also added to this resultant address 17000 from BX SI DS. Then physical address is generated 18050H At that address, whatever the data, here I am using 1, 2, 3, 4, that will be transferred to the AX. I am using move instruction, that's what the data available at this physical address, then that will be transferred to the AX register. Okay, likewise data can be specified in these types of ways. Next, coming to the addressing modes of control transfer instructions. If in case of jump instruction, call instructions, we have to specify the data like this. Okay, so the addressing modes depend upon whether the destination location is within the segment or in a different segment. Let us see. Addressing modes for control transfer instructions divided into two types: intersegment, intra-segment. Intersegment again divided into direct and indirect way. We can mention intra-segment also can be mentioned in direct way or indirect way. Okay, let us see intra-segment direct addressing mode. In this addressing mode, the address to which the control is to be transferred lies in the same segment in which the control transfer instruction lies and appears directly in the instruction as an immediate displacement value. Okay, effective address is the either 8-bit or 16-bit displacement plus IP. Okay, so IP ante instruction pointer kada, instruction pointer is used to store the address of the next instruction. Okay, so to that address, whatever the specified 8-bit or 16-bit displacement, that will be added to generate the next instruction address. For example, I am using jump 0050. Okay, so this is one code segment. Okay, so this is the main program. Whenever jump occurs, then jump to specified location 50. Okay, so this is after 50, then this 50 will be added to the IP, then processor or control jump to the specified address. Anyway, here main program and sub program both reside in same segment. Here code segment is used because instructions are stored in code segment only. Instruction, set of instructions nothing but program. Program nothing but code. Code is stored in code segment only. Okay, within the segment, next instruction within the segment అయితే దాన్ని ఇంట్రా సెగ్మెంట్ అంటాం. Okay, that address is can be specified directly or indirectly. Here if you use jump 0050, then we can say this is direct addressing mode. Okay, so that the displacement range may be 8-bit displacement range may be -128 to plus 128. 16-bit displacement -32768 plus 32768. Okay, in this range only we use address for jump or call instructions. Okay, like that in direct addressing mode, the specified address mentioned in the instruction directly. Okay, in the intra-segment indirect addressing mode, that address is mentioned in some register, or we can say that address of the instruction mentioned in an indirect way. That's what I'm using jump bracket of BX. Okay, BX contain 0050. Now coming to inter-segment direct addressing mode. See, అర్థమైంది కదా, ఇంట్రా సెగ్మెంట్ అడ్రసింగ్ మోడ్ అంటే ఏంటంటే మెయిన్ ప్రోగ్రాము తర్వాత ఇది సబ్ ప్రోగ్రామ్. మెయిన్ ప్రోగ్రాంలో సపోజ్ జంప్ వచ్చింది అనుకోండి, జంప్ టు 50. ఓకే, సో ఐపీ కంటైన్స్ అడ్రస్ ఆఫ్ ద నెక్స్ట్ ఇన్స్ట్రక్షన్. కానీ ఇక్కడ 50 వచ్చింది కదా, ఆ 50 ఐపీకి యాడ్ అయ్యి వచ్చిన ఎఫెక్టివ్ అడ్రస్ దగ్గర ఏ ఇన్స్ట్రక్షన్ అయితే ఉందో అక్కడికి జంప్ అవుతుంది కంట్రోల్. ఓకే, కంట్రోల్ విల్ ట్రాన్స్ఫర్ టు ద స్పెసిఫైడ్ అడ్రస్ within the same segment. That's what we can say intra segment. Okay, segment lo untundi next instruction. Inter segment. In this mode, the address to which the control is to be transferred lies in a different segment and it is passed to the instruction directly or indirectly. Okay, that means we can say branching from one code segment to another code segment. This example for direct addressing mode. In case of intersegment means, see, this is one code segment, this is another code segment. We have discussed in memory segmentation 16 segments are there, 4 code segments, 4 extra segments, 4 data segments, 4 stack segments. So here I am considering 2 code segments, code segment 1, code segment 2. Code segment 1 starts at 1000, code segment 2 starts at 2000. Okay, so here program resides in, main program resides in code segment 1. Suppose subprogram resides in code segment 2. Okay, so whenever call instruction occur in main program, that is 2000. Okay, this 2000 is the starting address of the code segment 2 and 0050 is the offset address of that instruction. Okay, then processor jump to the, whenever call instruction occur, processor jump to the next segment, and then with the help of this offset address 0050, then jump to the specified instruction. Okay, likewise this offset address is mentioned direct way or indirect way. Okay, so for example, call 2000H is the base address of the code segment and this is 0050 is the offset address. Okay, if we mention offset address like this, we can call it as a direct addressing mode. In case of intersegment indirect addressing mode, call 2000 bx of bracket. Okay, so if you use bracket, bx contains 0050. Okay, this offset address is mentioned indirect way. That's what this is known as indirect addressing mode. Next instruction address must be mentioned here. That instruction must be in the next segment, in different segments. That's what this is known as intersegment direct and indirect addressing mode. In this case, next instruction is available in the same segment. That's what this is known as intrasegment. Here the next instruction is available in the different segment. That's what intersegment direct or indirect addressing mode. If address directly like this, you can use, you can mention the address indirectly, we can use this kind of instruction. Okay, so likewise data specified in different ways, or we can say data can be specified in the instructions with the help of different kinds of addressing modes. Okay, thank you. We will meet in next video.